energy recapture system. Heat losses. Research has shown that we throw away most of our energy. Over 50% of all the energy we consume is wasted. Mostly as waste heat up a smokestack or over a tailpipe instead of performing useful work. But we throw away use the electricity as well. Why not recapture and save that wasted electricity for future use? This picture shows an example of heat losses. The roof costs 25 to 30%. Walls cost 25 to 30%. Floor cost 10 to 20%. Windows cost 25 to 30%. Energy recapture ventilation systems. Energy recapture ventilation systems provide a controlled way of ventilating a home while minimizing energy loss. They reduce the cost of heating ventilated air in the winter by transferring heat from the warm inside air being exhausted to the fresh supply air. In the summer, the inside air cools the warmer supply air to reduce ventilation cooling costs. There are two types of systems. One is heat recovery ventilators, HRV. The other one is energy recovery ventilators, ERV. What is the energy recovery ventilation? Energy recovery ventilation refers to the recapture of energy typically lost through the building ventilation process. As part of a preconditioning process, ERV systems transfer the energy from the exhaust into the incoming air stream. ERV is like a greenhouse to protect the energy. This picture shows how does the ERV works. The ERV has two fans in the cabinet along with the heat exchanger and a desk tent. The outside air fan draws air in from the outdoors. The exhaust fan 2 draws air in from the home, and the heat exchangers 3 heats or cools the incoming outside air, while the desiccant removes humidity. The picture shows how does the ERV works. This picture is in operation during the heating seasons. During the cooling season, the only difference is that the cold indoor air is used to cool the hot outdoor air. The airflow remains the same, so there are no complicated mechanical systems to switch over or think about. In fact, the only thing that needs regular maintenance are the filter. The ERV system for the University of Fukui. Energy recovery ventilation system usually costs a lot to install. If we want to make a ERV system into our university, it's important to save on installation costs. complex systems are not only more expensive to install, but they are generally more maintenance intensive and often consume more electric power. This picture is the air conditioning of my research laboratory, because many ERV systems can share the existing ductwork, so we can share the ductwork of air conditioning to the ERV systems. I want to have a supply and return ductor for each room and for each common living area. Ductor runs should be as short as straight and as possible. The correct size ductor is necessary to magnify the pressure drops in the system and thus important performance. Maintenance, energy recovery ventilation systems operation cold climates must have devices to help prevent freezing and frost formation. Very cold supply air can cause frost formation in a heat exchanger, which can damage it. Frost build up and reduces ventilation effectiveness. Energy recovery ventilation systems require more maintenance than other ventilation systems. They need to be cleaned regularly to prevent diminution of ventilation rates and heat recovery, and to prevent mold and bacteria on heat exchanger surfaces. Thank you for your attention.